Good afternoon, viewers at home. My name is Mr. Qazim. From Tendakem, I am science teacher from Tendakem MOTORSTOLIC International School. We are located in Cairo, Egypt. Today, we are going to discuss about chemistry. That is our subject for today, Senior 1. Now, our topic for today is bonding under chemistry. So what is bonding? Bonding is the process that occurs between two or more molecules of an atom by joining together chemically. So we need to ask ourselves, what is atom and what is molecule? An atom is the smallest particle of an element, like we all know. And what is molecule? Molecule is the smallest part of an atom which can exist on their own. So now, maybe looking at this, now we have types of bonding here. Here we have, there are two types of bonding. There are two types of chemical bond in compounds. Number one, ionic or covalent bond. Number two, ionic or electrovalent bond. Number two, covalent bonding. So let's discuss about ionic or electrovalent bond. Ionic bond is a chemical bond formed by transfer of electrons from the outermost shell of a melter to the outermost shell of a non-melter. Therefore, the force of attraction between the cation and anion is called electrostatic force. Let me preview with some example here so that you can understand what I'm trying to say better. So let me bring you with some example here in order to understand what I'm trying to say according to ionic bond. In ionic bond, you see from the example here, ionic bond in sodium chloride, that is NaCl. If you see it here before the reaction, and if you see here, this is after the reaction. If you look at this sodium is a very popular element that we know, and chlorine as well from your first 20 elements. Like I told you, this is a must for you to know. Without this, you may not enjoy this chemistry. You must know this and know their numbers, know the symbol. So with this, you'll be able to deal with this or anything relating to chemical equations. Like we know, sodium is one of the elements popularly known as Na. And atomic number for sodium is 11, as we all know. And chlorine, which is Cl, and the atomic number for chlorine is 17. If you can see it clearly here, now we have atomic number for sodium, which is 17, and atomic number for chlorine, which is 17. Now, if you can see me now, I'm going to break this down into electronic configuration. That is, I will have 2, 8, and then 1. For the chlorine, I'll break this down, which is 17, 2, 8, and 7. So if you see this, maybe looking at this one already completes the octet shell, which is the 8 of this sodium that is here. Why this need just one to complete its octet shell outside here. So now, the electrovalent or ionic bond will occur between these, that is sodium and chlorine. How are they going to occur? So now this is the shell for sodium. Okay, let me. This is the shell for sodium. So these two electrons will be here. The 8th electron, 1, 2, 3, 4, 5, 6, 7, then 8. Now, the last number of the electron, which is 1, is going to be outside here. Now we have sodium here. But for chlorine, we have 1, 2, then 3. Then we can place the electron onto the chlorine as well. That is 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. This one completes 8, and we have 7 there. 1, 2, 1, 2, 1, 2, then 1. Okay, let me do it like this. Let me move this one from here. Let me put it here, and let this one, although I can place it anywhere. It is just an electron moving around the orbit. Now this is chlorine, and this is sodium, this is chlorine. Now, if you can see here that sodium has 1 electron at the outermost shell, and chlorine has 7 electrons at the outermost shell. So now, chlorine is a melter because it has the power to give 1 electron to chlorine so that chlorine will complete its octet shell. What is octet shell? Octet shell is a process by which an element or a compound can be able to gain 8 electrons at the outermost shell. There are some elements like that they cannot be disturbed, neither share or by gaining any electron, like neon, like argon, and some other noble gases like that. So now, this must complete the octet shell, and this one must complete its octet shell so that they will be able to form the bonding. So what am I saying in essence is that this sodium will transfer 1 electron from this outermost shell. We lose this particular orbit completely and transfer this from sodium, then give it to what? To chlorine. Look at this electron will come from sodium here, then come to chlorine. Then this orbit will be removed because sodium has already transferred the electrons from here to what? To the chlorine. Then sodium will now remain as 2,8 because he already lost 1 electron. So that is why we call it melter. Any element that lost electron, we call them melter. Whether 1 electron, 2 electron, or 3 electron, they are called melters. But any element that can gain electron from other melter elements, they are called non-melter. Unlike chlorine now, it is non-melter because it gained 1 electron from where? From sodium. So now, chlorine here will become 2, 8, then 8. If you look at the chlorine now here, it becomes 2, 8, 8. If we are to look at this 2, 8, 8, which element has 2, 8, 8 like this? Which is what? Which is argon. The chlorine here tends to look like argon, but it is not argon. But due to the gaining of electron from sodium, it makes it to look like argon, but it is not argon. But in a chemical reaction, we will see it as chlorine. But by gaining the electron from sodium, we will see it as what? As argon. And if you look at sodium here, sodium already lost 1 electron. Now remain 2, 8, which is 10. If you look at this sodium, it gained octet shell. That is, this shell becomes 8. It cannot be disturbed again. It can't give again neither shell because already lost 1 electron to chlorine. And chlorine now already gained 1 electron to the outermost shell, then now become 2, 8, 8. Now that gives us 18, which is argon. But it is not argon, but somehow look like argon. And if you see chlorine here, now lost 1 electron to become like neon. It is not neon really. It is chlorine, but due to the fact that it lost 1 electron to chlorine, so make it to look like neon. It is not neon, but it will look like a neon. In this process, now this ability for sodium to be able to lose 1 electron to chlorine, we don't call it sodium atom again. We call it sodium anion. It becomes anion now. Now we don't call it atom unlike before. We call it sodium anion. And this chlorine as well, we don't call it chlorine atom or chlorine molecule. We call it chlorine anion because we already gained 1 electron to the outermost shell, becomes a stable octet shell, and this one lost 1 electron. We remove the electron, the orbit that carries the electron from here, and become 10, and we look like neon. It is not neon really, but I told you it is not neon. It is chlorine. But due to the fact that it lost 1 electron, make this to look like a neon. But in this process, we don't call it sodium atom or sodium molecule again. We call it what? Sodium anion. Then we put this down. Also like chlorine, we call it chlorine anion. So let's move forward. I hope you can see this if you are viewing us at home or if you are just joining us. This is chemistry for senior 1. So this is chemistry for senior 1. Let me see the video that with us. So, as I was saying, so this is the reaction that occurs. This type of reaction, we call it electrovalent bond because it has ability from melter to transfer an electron to what? To non-melter. Whether it is 1 electron, 2 electron, 3 electron. Let me show you more examples so that you can understand what I'm saying very well, apart from this sodium. But just bear it in mind that electrovalent bond will only occur when a melter element transfer electron at the outermost shell to a non-melter element. So another example, let me use let me say magnesium. Magnesium, which is Mg. That is, if you count from our first 20 elements, I told you have to know this of N: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. You can see we have 12, which is the atomic number for magnesium. You put it there. So now, oxygen. Let's use oxygen. Which is, if you have to count, I told you know it of N accordingly. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, which is what? Which is 8. That is the atomic number for oxygen. So let me put the chemical symbol, which is O, then which is 8. So now, breaking this down into electronic configuration, we know what is electronic configuration, fine. That this is Mg, which is equal to 12. Then I'm breaking this down into electronic configuration, in which I have 2, 8, then I have 2 here. 2 plus 8, 10, then 10 plus 2, making it 12, according to the number we are having here. And oxygen as well, which is O, which is 8. So breaking this down into electronic configuration, I will have 2, then I will have 6. 2 plus 6 making 8. So now, if you look at this magnesium is a melter because it has 2 electrons at the outermost shell. I told you, every melter can be able to lose more than 2 electrons, but from 1, 2 up to 3. When they lost such electrons from 1, 2 to 3, we call them melters. But any element that can be able to gain that electron, we call them non-melters. So now if you look at this now, it is melters. So let me put it in their shell. This is magnesium, Mg. Let me say magnesium molecule. Let me put magnesium molecule. At the first stage, it becomes molecule or atom. So now I have 2, 2, then I have 2, 2, 2, 2, 2. This one becomes 8. And at the outermost shell here, the final shell, which is 1, and I can put this one anywhere, making 2. So magnesium molecule, and I'm having oxygen here as well, which is 2 shell. Now I have 2 here. I have 1, 2, 1, 2, 1, 2. So now, if we look at this, magnesium and oxygen molecule, the electrovalent bond will take place here. The electrovalent bond will take place here. That is, the 2 electrons at the outermost shell of this magnesium will be transferred to the oxygen. That is, this shell will go off completely. 1, 2. So we lose this particular shell, the outermost shell here, completely. We lose this completely, and this we get the 2 electrons. If you look at this now, the magnesium lost 2 electrons to oxygen, and oxygen gained 2 electrons from magnesium. So now this magnesium tends to look like neon, like I said earlier, neon, and the oxygen as well looks like neon at the same time, because both of them complete the octet shell. What is octet shell? That is, if you have 8 electrons at the outermost shell. If you see this, because it lost 2 electrons to oxygen, complete octet shell becomes like neon, but it's not neon, it is oxygen. But at this point, we don't call it oxygen molecule any longer. We call it oxygen ion. Oxygen ion. And we don't call this magnesium molecule any longer. We call it magnesium ion because it lost 2 electrons to oxygen, and oxygen gained 2 electrons from magnesium. So they both become ion, not molecules any longer. So that is just another example from this, and we have many examples like that. It is very easy for you to identify them when you know the melters and non-melters elements. Like I told you, you need to know your first 20 elements of earth from hydrogen to calcium. So then you'll be able to do this and understand what chemistry is all about. Without this, you can't go anywhere in chemistry. So let me show you some reactions again. So we have this. We have here. I'm trying to let you know the chemical equation I'm putting on the board.
Tell them if the meeting disconnects, that they should connect again and you start another meeting because the time is up. But if this one ends, that they should connect again. You will start another meeting for them. Tell them. Okay.
So if the time is disconnected here, so you can restart the meeting again because I'm continuing the lesson now. If you are listening to me,
Alisa.
Alisa. So have 2, 8, Na plus 2, 8, minus. So what I was trying to tell you is, if you look at, this is the equation for the sodium chloride. This is before the reaction, and this is after the reaction. You can see from here, this is Na plus Cl. That is, Na, it carries a positive charge here, that is, lost 1 electron, and Cl carries a negative charge here, that is, gain 1 electron. If you look at here, this is NaCl. At this point, it is molecule, like I said earlier, 281. There are still molecules here, and chlorine, this is 287, still molecules. But if you look at here, this one already disappeared, become 28 just, without the outermost electron. So this one serves as the outermost electron now, which is the 8. So making it what? Anion. And this, from 287, gaining 1 electron from sodium, becomes 288, making it what? Anion. So that is just that. If you see, this is the chemical equation. Na, that is Na plus lost 1 electron. This is 1 electron. This E represents electron. So this is chlorine, Cl plus 1 electron minus, that is Cl minus, gain 1 electron. So now the chemical equation here says Na plus Cl minus, that is NaCl. This forms sodium chloride by attraction. So now you can see here 28Na plus 288Cl. This is anion, like I said. Not molecules again. Then we have NaCl. So I think from this point I would like to stop now. So if there's any question or you have any comment, you can drop your comment in the video link, and you can let me know. If you don't get what I'm saying better, you can ask more questions. So when I come online again, so I'll be able to answer your questions. So let me see if I can give you some. Okay.
Okay, you're looking at image.
So let me see if I can. So now, the viewers at home, if you are still here with me, this is your own work from the class we just had now. You can just solve this on your own. So let me know if you understand what I've been teaching so far. This is a part of what I just taught now. You can solve it and let me see if you really understand. The question says, an ionic bond is formed by dash of electron from metal to dash. The resulting positive ion from the dash attract dash ion from the non-metal by a force called dash. So you fill this gap here. So let me see if you really understand what we have been teaching so far. And if you have your textbook, you will see many questions there. I think chemistry senior 1. If you are with me, you can see this chemistry senior 1 from the textbook. You go to page 77, you will see the questions there. So if there's any question, you can drop it. You can go to our YouTube, Tender Care MOTORSTOLIC. Then you will see all our videos there. So if there's any comments, you can drop it. So thank you very much.